Hi everyone, welcome back to another session again with me here on Think. And today again we're gonna go crack another Uceed question because we're this close to this year's examination, and I'm pretty sure all of you guys are working really hard and all of you guys are like super prepared. So even if you guys are one of the people who said, okay, let's try this, in the last minute, because a lot of even my friends are trying to crack this in the last minute. Don't worry about it. And just because it's a lot of common sense mixed with a lot of, let's say, being, a little creative and a little bit of practice. So let's try to see what we can do today. All right. So, hello everyone, and let's start. All right. Hmm. So, this is today's question. Women in rural India have to walk a long distance to carry 3 to 4 pots of drinking water to their homes. This causes a lot of physical strain. So, you guys might be aware of all the diseases that these women in rural India develop by years of strenuous activity, especially out in the sun, right? So, design a device to help women carry 4 earthen pots of drinking water through uneven terrain. Identify at least 5 distinct factors essential in this device that will make it relevant for rural India. So again, this is very important, guys, how they structure the paper. They are going to use keywords and numbers, and each of these numbers might carry, not might, will carry a mark or two each. All right. So this is your marking scheme. So you can read the question, but I will tell you how to kind of put X-ray vision glasses through it and see the question as not just a sentence, but a marking scheme in itself. Right. So that is what is important over here. So 4 pots, earthen pots, right? Those are keywords. Then uneven terrain is a keyword, right? Distinct factors, 5 distinct factors is another keyword, right? Rural India is another keyword. So these things come as keywords that you have to kind of circle with a pencil or jot down in a rough sheet next to you, because when you're designing, these are the things that are going to come up as these are the things that are going to come up as either factors or pain points or things to consider. Like rural India translates to limited resources, it translates to um, less costly materials, it translates to easy to build things, it translates to maybe let's not depend on a lot of technology and things like 5G, right? One word can speak a lot, so you have to think in that scope, and these words actually help you define the scope of what you're trying to build, what you're trying to assess, and the problem that you're going to solve, right? Another thing over here, we have the word uneven terrain, right? So that's another important point. We will see how to work around these words. All right, so let's proceed with the question. So don't just read the question. Okay, maybe read it once, but then the second time you have to not just read, but you have to annotate and analyze it. So what do I mean by annotate and analyze? Like analyze, yes, of course, you have these keywords, you have to read it, like the word rural. I came up with so many kind of things that you have to keep in mind when you hear the word rural, right? When you're designing for something in a rural setup. And similarly, you have to annotate, so you have to circle the important words, so that when you're when you start sketching the product, you don't kind of forget, right? I mean, you keep remembering that this is what it's going to be in, because sometimes in the flow you might miss out a point, but if you have it circled, you do not miss it out. And that is what we are trying to do over here. All right, so let's move on. Present your design proposal with a neat freehand sketch, and so that is going to be your main, let's say, the hero shot of the product, right? And it's going to be a freehand sketch. That means that you are not going to go into the shading a lot or the textures. You're not going into hyper realism. It is going to be clean lines. If you want to convey or communicate surfaces, you're going to draw contours. And if you really need to convey or communicate something, you're going to draw, like you're going to render shadows and all of that. But we are not looking at a hyper realistic sketch, because this is something that a lot of students ask, that what is the quality that they are expecting. Because ma'am, in Pinterest we have seen people render the color and even the material. Plastic looks like plastic, metal looks like metal. Do we even get graded for that? No. You are not going to get graded for a metal piece of metal, like the handle, let's say, looking like a metal. It should look like a handle. It should communicate. Over here, drawing is not, it's a little different from the concept of fine arts that we have been accustomed to growing up, right? So in design, drawing is a tool rather than a skill, where yes, neatness is appreciated, yes, line quality is extremely important, but in the end of the day, it's about, can your drawing speak? Can your drawing communicate? It's a tool for communication of ideas, of form, of function, of movement, even. Right. So that is what we are trying to target. All right. So yes, I really hope you guys can see my screen. If not, kindly let me know. Let me share my screen again. All right. Are you guys able to see my screen? Please drop a yes. Yeah, I think you guys are able to see my screen now. All right. So let's read the question one more time. Women in rural India have to walk long distances to carry 3 to 4 pots filled with drinking water. This causes a lot of physical strain. Right. Design a device to help women carry 4 earthen pots through an uneven terrain. Identify at least 5 distinct factors each. Now you guys are able to read the question, and you guys are able to kind of break this down into what exactly we have to read. All right. So the first thing is that you have to create a neat freehand sketch. The second thing is that it has to talk about the usage scenario, and the third thing is that you have to talk about the CMF, or the colors, material, finish, and kind of give an understanding of, okay, I am not intimidated by, let's say, talking about manufacturing processes. So over here, please don't get afraid, because a lot of people get intimidated, like, oh, I come from a background of, okay, I know how to draw and I know how to tinker, right? Even I, before my formal design education, I was like this. So when you hear the words processes used in manufacturing, all they're expecting you to say is things like, okay, this is going to be a cut, this is going to be a metal sheet. You can just explain a general idea. They're not asking you to explain how it's going to be manufactured from top to finish. But yes, reading up about manufacturing processes and how certain things are made, and being curious about it in the next couple of days will help you a lot, right? So you guys can look into resources. You guys can just Google, how is a balloon made, right? That's something I was very curious about when I was a little kid. How are certain chairs made? Most chairs are made using one single rod, which is bent according to the design, and then a piece of leather is stretched into it, right? So there's different types of manufacturing processes, and it's really nice to read up on it, right? And again, you'll have to end this question by writing a brief note on the design decisions. Right over here it's a maximum of 100 words, but please remember that even if it's a maximum of 100 words, even if you write 50 words, throw in as much sensible jargon as you know, right? So throw in words like manufacturing material, or feasibility, usability, inclusivity, pain points. So these are a lot of the design jargon that I keep talking about in our YouTube sessions, and you guys can feel free to use them in the correct place in the correct time, and that will elevate uh, your writing. And you guys can even use annotations, especially where they've asked for, right? And you guys can even write in bullet points, as long as it's making sense, and it's not like you're trying to fill in the words, actually, because that is sometimes more effective than paraphrasing, and your ideas get lost in your sentences. So let's move into how to crack this question. All right, first thing is to understand heavy lifting ergonomics. So this is a particular type of question where a human being and their body is heavily involved in working with the product, right? So this is one of those products where ergonomics plays a huge role, right? So handles and things where you have to lift something, and this is an aid to lift something, or even chairs, right? Tables, things where you have to interact, furniture. Those are all products which have a heavy influence on the word ergonomics. So I really hope that you guys are aware of the word ergonomics. If not, just chat. All right, but in simple words, it's just the science of trying to understand how a product fits for a person. Okay, somebody said no, so I will explain. Let's not go into a lot of technical terms here. I'll explain it in simple words, but it's basically just this. In our design process, this is just something, or a pit stop that we make, and a checking point that we do to see if everything works. It basically means that it's science of holding things and saying that okay, this feels right, it fits right, and it's the right dimensions for me as a human being. So if I create a chair, right, it shouldn't be too short, it shouldn't be too tall, it should be just right. So creating something that is proportionate to the user. All right, it's not like exclusive for a human being. Let's say that I am creating uh let's say a bed for a dog, for my pet, right? So I should take dogs ergonomics into consideration, right? Their body, the way they curl up when they sleep, their curves and their size, their dimensions, right? And even in that you can go into specifics, but it is a good practice to look into that, how. And especially one thing, it's not about comfort, it's about, yes, kind of, not completely, it's about measurements and making it proportional to the user, and also making it yes, comfortable and safe to use. So over here if you see the image, right, there is the right way to pick things up and there is a wrong way to pick things up, and it all has to do with posture. And when you talk about handle ergonomics, or even ergonomics of a remote, it really revolves around posture, right? It really revolves around things, the way you hold it, and whether you can reach all the buttons or not, right? So it's a big umbrella term, but right now what you just need to understand is, does it fit the context of my body? Does it fit my dimensions? Does it fit my form and the way I twist and turn or lift and walk? Right. So that is what this is, and you guys can read up a lot of interesting case studies done on ergonomics and product design. And if you don't know about this word yet, please do explore a lot, right? So in this class I will just move on to how to design and how to crack this question, because ergonomics is a it's a huge subtopic, right? It's a huge umbrella term, and there's so much to explore there. All right, all right. So this is one product that I came across, right, while just casually surfing the net, and this was quite interesting because it's something that's collapsible. So at least one way forward, the women don't have to carry anything. And this was another alternative where it's, I feel like, a little more rigid than this because of the form, right? But then it came to a point where I went back to the question. So this is where that whole circling and the annotating comes into play. So let's look at the question one more time. It said carry 4 earthen pots. So we are not supposed to design something to carry water, right? This is a mistake that 90% of the students made in this year. In the year this paper was there, they did not design to carry the pots, they designed to carry the water. And even me, I also tried to do the same thing in the beginning, and then I went back to the question, and then I realized, no, you have to design something to carry the brittle, bulky thing that is the earthen pot. So now this makes the question much more difficult. And so let's go back. This is just an example product and how somebody has sketched it. The reason why I've put it here, if you guys can see, is to show you how annotation works. Right, when I say annotation, I'm drawing the product very neatly, clean lines, and then I am drawing this little squiggle kind of arrow. Learn to draw this arrow, and then I am writing my bullet point. Right. So this arrow is something that screams product designer. It's just a hack. I just put the slide in here in the middle with no context just to explain this one point. And yes, of course, when you're talking about, explaining the posture, or the position, or how it's used in a person, you can draw the figure, human figure, or the human using it, interacting with it, and you can always highlight the product and then annotate that. It's always part of the best practices, or something that you can do to kind of elevate your profile, or elevate your answer sheet. All right. Okay, so let's look at how usually this question is cracked. It's cracked through um, yes, somebody said, but the question said they needed to design a device. So, yes, you have to design something that can carry it. So, a device is again like a very broad term, right? It does not necessarily mean it's a electronic gadget, right? So, be very mindful of the terms, and be very mindful of the limiting beliefs that we have, as what these words mean, right? So in the other class as well, I explained this one analogy where we have a limiting belief that if we have two slices of bread and something in the middle, it's a sandwich, right? And then technically, is burger a sandwich? Are we really having a limiting belief that burgers are not sandwiches? So it's something to think about. But yes, they did not really mean an electronic thing. It They literally just mean like a gadget or a contraption, right? So let's go back to this. And this is the flow, what you see here on my screen. This is the flow of what a typical product design or a design process looks like, right? It's not a linear process. Over here, it looks quite linear, but usually we circle back to even stage one if things don't work out and loop back to the release. But over here, why did I put this is because I want you to understand the first point, that is empathize, learning about your users. The flow goes empathize, define, ideate, prototype, test, and launch. Right. So the first point is the only one. The first and the third point is the ones that you are going to be tested on in the UC paper. Empathize and ideate. Right. So empathize how? Empathize why? So we'll have to go back to the user and we'll have to understand the typical rural woman. Right. So if you have seen any of these women carrying their earthen pots, they have a very traditional posture. And one interesting thing about them is that their spine is always straight, which means they have kind of learned over time that, this is how you avoid all these illnesses, and this is how you can endure and go through this for a long time. And what they do is that they have already understood that it is a stackable form, right? And it's not necessarily something that is spill proof, right? So what I've done here is I've kind of noted down the you know surface level. There's much more, but surface level pain points, and one good point that I was able to come up with, one is that it spills. Next pain point is that it's brittle. It is stackable. That's supposed to be a plus. Sorry, and it's bulky. That's another pain point. It's heavy. So bulky and heavy are two different things. Please remember, a huge block of thermocol can be bulky, but it's not heavy. Right. A small kettlebell is not bulky, but it is heavy. Right. So you guys can feel free to use both of the terms or any of the terms according to the situation, and please use them right. Okay. And the one main plus point and the main reason that we cannot get rid of this is the fact that it is affordable. Unfortunately, earthen pots are affordable and it is okay. They can afford to break a pot or two, and it keeps the water cool and all that, but it's not relevant in this use case scenario because we are specifically focusing on lifting and carrying. All right, so let's move on to the next image. So this is just this one common idea that everyone has, right? So this is another one of the common ideas that everyone has. So my idea over here by putting this is to tell you guys that don't put the first idea that you have on paper. Keep ideating more on a rough sheet. Keep thumbnailing, because 90% of the students are going to draw either this or this, something like this with shells or something like that, and they're going to call it a day. And for anything bulky and heavy, this is pretty much the same design. Even if you have something very similar, let's at least try to incorporate something interesting, like something that will stick, something that will be like, hey, this is something that I didn't see in the past 500 papers, so let's move this paper to the selected list of people for UC. So that's what we're trying to do here. All right, so one more time, question breakdown. There's four other parts. One thing that you have to look at is uneven terrain, right? You have to create a sketch. You have to, annotate the features. Use case sketches you have to create. So basically, just like what we are seeing over here with the human being and the product, the human being interacting with the product, and CMF and manufacturing notes. Over here, I've used a technical term called CMF so that you guys are also exposed to this. Does anybody know what CMF stands for? Okay, it stands for color, material, and finish. Okay, so it's just a fancy word. It literally just means what it looks like and the material. but it's something that you can throw in into your notes about the product notes. So CMF and explain 2 and 3. Okay, so point number 2, it says use case sketches. So nothing more. The question literally just said that please draw the human being using the product. Okay, so it will be, one image will be the woman struggling with the pots, and the second image will be the woman holding the product. So you know how to use, or the posture of the woman with the product. And and maybe another image can be how the woman is opening the product if it's an openable thing, or how the woman is placing the pots inside the product, removing the pots from the product. Those are the use case sketches, and these don't have to be highly technical realistic drawings. Okay, these can be a little rough, but when I say rough, I just mean that you're not going to go hyper realism on them. I still expect clean lines, and I still expect good line quality, and for you guys to use a low graphite pencil. So what is a low graphite pencil? And a double H or an HB or something like that for drawing the rough lines, and max to max a 4B if you want to draw the outline, or outline it out, right? But please do not use 6B and all of that, 8B and all of that in your answer sheet, because no matter how much you try, unless you, even if you put a fix it spray on your paper, it will smudge and it's going to leave a very bad impression. And smudging is something that is unacceptable in any of these design colleges, so please be very mindful of that. Point number 3 is CMF and manufacturing notes. Let me repeat: CMF and manufacturing notes. CMF stands for color, material, and finish. And then we have our manufacturing notes, which means nothing. It's just a big word. Like I said in the beginning of this video, it literally just means a couple notes on, okay, this is going to be put in a lathe machine, or let's say that this is going to be bent, heat bent, right? So it's a good idea for you guys to expose yourself to some basic common manufacturing techniques, but it doesn't have to be. Hello, am I audible? Hello. Hello. All right, thank you so much. Yeah, it doesn't have to be something that is, very technical and very difficult. All right, so you guys can just keep it clean, keep it simple. And CMF, I'll give you an example. You draw that squiggly arrow, and you say plastic. If you want to go fancy, you say HDPE, plastic, high density polyethylene, right? That is the hard kind of plastic. If it's a flimsy plastic, you can write LDPE, or low density polyethylene. But again, be very mindful, don't use these words if you don't know. You can just write plastic. It has equal value. Stainless steel, 90% of your products are going to somewhere have stainless steel, so you can write that, right? So those are the things. When it says material, you just have to label one or two materials. And if there is something interesting, like if you're making something that is, let's say it's something like a fireproof ball or something, and you decided that you're going to cover it with Kevlar, then of course you will have to label it and say Kevlar. And that's it. And then of course in the end you're going to conclude with 100 words of your design decisions. So how do you write, what exactly are design decisions? It's basically like, okay, I did this because this was like this. I used a gyroscope because there is spillage, right? That is the kind of concept that we are trying to do. So this was my rough sheet, okay? And I'm very vulnerable out here putting my rough sheet in the internet. But this was my ideation phase. I started off with a simple trolley, the first idea that we saw, right? And then I realized that, okay, how about I make it a vertical trolley? But then I realized, okay, there is a huge spillage problem over here. Then I thought that maybe let's look at one pot and let's do something that's modular. And then I was like, okay, that's something that I can do. So I hope you guys are aware of what the word modular design means, right? So modular means that, okay, there's one unit and then there are many other units and you can connect the units or they can fit together, right? Like Lego blocks. That's what modular means, right? It's a much more expansive concept than Lego, but let's just think of this analogy to quickly understand what modular means. So I thought, let's just design something for one pot and let's make it like, okay, this is for one, but if I can still stack, or I can still line up and do this for four pots, let's say. Right. And my main inspiration, I started with something like Dyson's ball barrow design. If you guys are not aware of that, please search it up. It's quite interesting. It's one of the first product designs by Sir James Dyson back in the day when he was very young, in his early 20s. And then that's when he started, that's after that he went up into his interesting thing. So then I thought, how about a hinge? How about I put it in a container that has a hinge and make it spill proof, like the whole gyroscope concept. So this is where I started thinking. In my third idea, in my fourth idea, right? And it doesn't need to take necessarily that much time, right? So just something that you guys will have to explore. And of course, this is just a very simple, yes, this is just an image to talk about modular, right? So it's pretty much like Lego blocks, and you guys can use this word or throw in this concept as well in your coming exam if it is something that is relevant. All right, so let's all right, so this was my final concept, kind of, where we have the handles and we have something like a ball and socket, and I was like, all right, maybe it's a gyroscope. So the outside one is the red ball, the inside one is the gyroscope that always stays in that position no matter what, and the outside ball can rotate. So then I went on to create the hamster ball concept, right? So if you guys know how the gyroscope works, you'll completely understand what this is. So in the this is the outer ball, which also acts like a wheel, and it's a large wheel, so it's easy to work in a terrain, right, in a tough terrain. But inside is basically, because of the gyroscope, this always stays horizontal and it does not spill. And of course, I've given a little bit of tolerance for the different sizes of the pots and even a little bit of spill, so that is there. But again, the smaller designs, that smaller sketches, it's just showing how it's opening, how it's going to be closed. But yeah, this is pretty much my version of how to approach this. And yeah, so that's pretty much it for the day. Does anybody have any questions about this, or about anything else in general, on how to approach UCEED from a product design angle? You guys can type it and I will get to you. All right. Yes, so this is like what I did for one, and I thought that, okay, just like wheels, we can stack them in front of one another. So ideally, I would sketch them out, but yeah, uh, it's just a thing that I still have to figure out. Actually, I just came up with this one idea, so I put it up. But yeah, we can ideally do this for three or four pots where you can stick them up like wheels, like rollerblades. Like that was the concept that I had. And then you can open it or close it and see what works. Right. All right. I would like to wish everyone good luck. And I'm pretty sure that all of y'all are going to ace this year's UCEED exam, and you guys are all going to pass with flying colors. So, good luck, you guys, and thank you so much for being here today with us, I think. All right. So signing off. Bye bye. Thank you.